This is still part of section 3.1. And so we're looking now at the alternate definition of the derivative. So this is the alternate definition for f prime of x. And this is f prime of a. So this is finding the derivative at a point. And when I say point, at the point where x is equal to a. And it is equal to the limit as x approaches a of f of x minus f of a over x minus a. And if you think about this, this looks very much like the slope of the secant line. It's just we've changed the b to an x. Remember, f of b minus f of a over b minus a. But here we're saying that a is approaching our b value, which is x. Okay? And so it's becoming our secant, a slope of our secant is becoming the slope of the tangent. Okay? So we'll do an example of this, of using this. Let's see if I can fit this on the same page. Is if we want to find f prime of a when f of x is equal to the square root of x. What is f prime of a? In other words, we're saying what is f prime of x equal to when x is equal to a? So what is f prime of a? And it's going to be the limit as x approaches a of f of x, which is the square root of x, minus f of a, which is the square root of a, over x minus a. And that is the limit as x approaches a of, and what we're going to do, let me grab this. I'm going to multiply this by 1. Multiplicative identity of 1 says if you multiply something by a 1, you do not change its value. But I'm going to express this, what I'm multiplying by 1, as a ratio, and it's going to be the conjugate binomial of the numerator. So instead of the square root of x minus a, it's the square root of x plus a. That's the conjugate binomial. And so that's going to be this, what you see in red is the value 1. So the numerator and denominator are going to have the same value. I'm going to put them in parentheses because these are binomials. And I'm going to multiply them by the original ratio, which is also a ratio of two binomials. So this is equal to the limit as x approaches a. And don't forget to write this each time, especially on the AP exam, because they'll take points off. You write the limit as x approaches a until you resolve the limit. So if we FOIL the numerator, well, what we're doing is we're multiplying the product of two conjugate binomials. And the product of two conjugate binomials is the square of the first minus the square of the second. The square of the square root of x is x, and the square of the square root of a is a. So it's x minus a on top. And then on the bottom, if we FOIL this out, we should get, let's see, x times the square root of x is x square root x. X times the square root of a is x square root of a. A negative a times the square root of x is a negative a square root x, and a negative a times the square root of a is a negative a square root a. Let me extend this. Now, what's happening? X is approaching a. X is approaching a. Let's resolve the limit as x approaches a. Actually, let's not do that quite yet. Let's not do that quite yet. Let's clean this up. The limit as x approaches a on the bottom. Okay, let's leave the top, x minus a on top. If we look at the bottom, actually, what we have, I'm going to move this around a little bit, but this should actually resolve as the square root of x. This should resolve as x minus a times, oh, you know what? I jumped ahead. I'm sorry, I made a mistake here. I did not need to, I overworked it. Let me just fix this here. Realize I've overworked it because, let me get rid of the bottom. I wonder if you can see. Can you see how I overworked it? Anybody notice what I did that I didn't need to do? I did not need to FOIL this denominator. Let me copy this. Let me put it back here. Okay, I did not need to FOIL the denominator. Do you see why I overworked it? Yeah? You see it, right, Brendan? Yeah. What I should have done is left the denominator alone because the x minus a cancels out, right? My mistake. Okay, so this is actually equal to the limit as x approaches a of 1 over the square root of x plus the square root of a. Now the reason we worked all this out is because if we had just tried to resolve it initially without simplifying this or modifying it, we would have had a divide by zero error, right? Because if right where I highlighted it, if we went ahead and let a equal x, or x equal a, x approaches a, we would have a minus a in the denominator, and what happens is we have a divide by zero error. So the reason that we did this work was to get rid of the divide by zero error, which I've gotten rid of now, right? Because now, if I let x equal a, I have 1 over the square root of a plus the square root of a, which is 2 times the square root of a. So that means that for this particular function, and we can go ahead and put the answer in right here, that f prime of a at x equals a is 1 over 2 times the square root of a. Okay, we'll highlight that. That's our answer right there. And this is using the alternate definition of the derivative, which we have right here.